Okay, I think we are ready. We're way earlier than normal today. I still have that camp going on, so I've got to get over to that. But I thought we'd get at least a little bit in so that we didn't miss today. I'll keep the video up like normal, so probably no one will watch it live, but that's okay. We'll catch up later, and next week should be back to normal 8 o'clock with the regular streams. So the last time, what we did was we were on this guy. Well, he's down here now. We were making replacement wings for this one. I don't see where I printed one. Don't know where it went. But I got to realizing that this printer has a 0.06 nozzle in it, and we were counting on, remember when we went through and designed the wing, we took a picture of it, and then we brought that picture into Fusion, and we were designing it with the idea that the thickness of our layers was going to be 0.15 millimeters. So this printer has a 0.6 millimeter nozzle, and that layer thickness is just a little bit too thin for that nozzle to do well with. It could probably try and do okay, but I figured it's also a good time to do a nozzle swap so that you can see how that works. Because sometimes you'll have to out of necessity, like the nozzle wears and it's just not printing at all anymore. Let me give you an idea of, I don't think I have a worn one, but we can draw some pictures of what we're talking about here, so that you have a decent idea of what is going to happen over time. So let's see, your nozzle. See if I can get this. Oh, why are we not working? It's gonna be a pain today, apparently. So, wonder if it gets better if I do this. We may not can draw very. It's all off. It's Let me try a thing or two here and see if it will behave itself. It may and it may not. Oh, I know what I could do. Hold on. We need to reset this thing. It shouldn't take very long though, if it will cooperate and I can remember how to do it. Reset setting. Let's do that. Oh, and I found the one that we printed part of. So we can look at that while it's already done. So we printed this guy. So this was the part facing the bed. That came out pretty good. And then we had problems on the other part of it. So I think what we've got for our model, now remember I didn't put all the details in, but for our model is looking like it's going to work, once I get the whole thing printed, and maybe not in blue, although the blue doesn't look that bad, and mirror it in either the slicing software or the CAD software, and we'll have some replacement ones. Now this particular one is PLA, which, well, it fell over there, which is a little more brittle. So we're also going to talk about PETG today and some of the things that are a little bit different with printing that. So our two things for today are, we're going to talk about PETG. We'll do that in a minute. And we're going to talk about, or we're going to do a nozzle change. Let's see if our screen is behaving better now. Yes, it is. All right. All right, let's go over here. And let's talk about this nozzle, why you're going to have to do at some point a nozzle change. There's a couple of reasons. One reason is that the nozzle wears out. So what can happen is, I don't have a gold color. Can I add a gold color? There's one. All right, so this will be our brass nozzle. So most of the printers that you start with, they initially have a brass nozzle. So brass because it's a good conductor. It is metal, and it's a good heat conductor. But as you are printing, I'm only showing the nozzle part, so there's some threads on here. It's screwed into the heat block, all that kind of stuff. And the filament is going to, we'll use red filament. So you're printing along the this red line here is going to be your layer. It's kind of thick in one spot. I don't know what happened there, but we got a thick spot somewhere, and you've got a bunch of layers stacked on top of one another. And the abrasion between the nozzle tip right in this area. Make sure, yeah, I think you can see that. Well, let's do screen. This area, as the nozzle rubs across the surface of your print that it is currently printing, then it will wear down, and some materials will wear it down way faster than others. So anything that's got a particle of some sort in the material, so a carbon fiber particles that are in there, or even the glow in the dark filament, those glow in the dark particles are abrasive. So any material that has an abrasive insert into it is going to make this happen even faster. It will happen with just regular printing, but it takes a really long time because it's just plastic. But other materials that you might print could have other particles suspended in them that would cause this to happen a lot faster, particularly with a brass nozzle. And so what will happen is inside that nozzle, the filament, it has a path that looks something like this. So it comes down, and then somewhere towards the end, it starts tapering in. Let me redraw how that's going to taper. It'll look something like that, but I want I want it to be more dramatic. So let's do it like this. So it tapers in to get down to the 0.4, or in this case of the printer that we're using here, it was set up with a 0.6 nozzle, 0.6 millimeter. And as you grind the nozzle away, suddenly this isn't the tip of the nozzle. The tip of the nozzle is, I'm going to do again extreme. The tip of the nozzle is up here, and so you've lost all of this material, and now the nozzle diameter is way different. It may not even be round. It might be a different shape. So that could be a different problem. But the nozzle diameter itself will be different also. And so all your settings and your slicer and everything that we're counting on that nozzle diameter being a circle and being 0.4 millimeters, now it may not be a circle. It probably is still circular, but it's going to be potentially larger than 0.4 millimeters, and your prints they'll still print, and it'll still look okay-ish, but you'll start having where it won't adhere to the bed too well, because now there's some distance here that's just gone, right? And so all your Z settings are going to be off, so maybe you adjust something and you do get it back printing, but even then the nozzle diameter is different from what you planned on, or what your slicer planned on. So you'll have some issues. It'll still print probably, but the prints just won't be as good as they used to be. And so that's one reason that you might want to change nozzles, is that it's just worn. And so if you're just printing regular materials, nothing fancy as far as object particles in the filament, so no carbon fiber stuff, no glow in the dark, no wood feel, any kind of the feel, any filler that's in the filament is going to cause this to happen faster. But if you've just been printing PLA and regular stuff, then this will happen, but it'll be months. Well, it depends on how often you print, right? So if you print daily, constantly daily, then maybe it won't be but a couple of weeks. But if you print some of the abrasive stuff in the brass nozzle, then it might be half a roll of the filament, and it's not printable anymore. So that's one reason you might change. Another reason is you might want to avoid that, right? So you're going to print abrasive materials. You only print in carbon fiber PETG because that's what works for your application, and you don't want to be changing brass nozzles all the time. They do make other types of nozzles, other materials, And so the most common thing you would do is you would get whatever diameter you want. Now, normally, if you're using some of the filaments that have filler in them of whatever kind, carbon fiber, wood fill, brass, well, there's a steel and there's a copper fill. There's all these different fills that you can have in the filament. You normally go up a little bit in the nozzle diameter size so that the filler itself doesn't clog up the nozzle. And so you normally want to go to a larger diameter, and you want to go to a harder material than brass. And so let's see if I can find my cursor. There it is. If we went over to check out some other materials here, let's see, nozzle, hardened steel, hardened steel. So, well, these the first ones that came up are actually really fancy nozzles. These are like $100 each, these Diamondback nozzles. Okay, I think we're back in business here. So, these are really expensive because they actually have a diamond tip, not like a jewel diamond, but it's a diamond material. And they essentially never run out, but they maintain a lot of the heat propagation properties of the brass material. So this would be something if you were really serious about, you don't ever want to change the nozzle, you want to get the printer set up, and then it's kind of in a production facility. They do make those, and that for whatever reason Amazon fed me those at the beginning, but normally I'm thinking of something like this. So this second pot here is, I've got 7 different nozzles of different sizes, and $13. So now I'm at $2 a nozzle versus $100 a nozzle. Here's another set for $10 for 8 of them. So I'm getting closer to $1 a nozzle. So the things that you want to check out here are the thread patterns. Make sure that you are using thread patterns that are compatible with your printer, which almost all of them now are. But there are a couple of the specialty printers that use larger diameter nozzles or maybe a slightly different thread pattern. What's more likely is not necessarily the thread pattern, like the pitch of the thread and the size of the thread, but the length of the amount of threaded region. So like this nozzle here in the middle, the brass one, well, this is one of those Diamondback ones. It looks like it has a longer throat area here versus some of these others. That will create a problem that you'll have to deal with if you get a longer throat nozzle than what you would normally have in your printer, because these nozzles have to screw into the heat block, and then they usually go up against the heat break. And so if there's more nozzle length there than you had before, now your Z is going to be significantly different. You're going to have to rehome. You probably need to do that anyway, but it will be significantly different, not just maybe it's very minorly different. So these hardened steel nozzles, they are not as good for heat conduction because now I'm using steel versus brass, but they are much better on wear. So if you're using a material, a filament that is you're afraid it's going to wear your nozzle down faster, then you will probably want to switch to one of these hardened steel nozzles. Most materials, actually, I don't think of any materials on their own are going to be a problem. It's when they have a filler in them. So it's carbon fiber filled PLA or something like that, or glow in the dark, or it's got some special property that's not just plastic. And there are there's 4 categories, I guess. There's the special ones like this Diamondback, there's rubies, there's all these special ones. So they're all kind of by themselves. And then this is a brass nozzle, which is what you usually want to use if you can, because of the heat conduction properties are better. Then there's the hardened steel, which sometimes you have to use because your material is just too abrasive. And then there's kind of a hybrid that is brass, but it's been nickel plated. I'm not seeing any of these right now. Oh, look, there's an example of one that's got a way longer throat than some of these others. So you do have to make sure that the nozzle you're getting is going to fit into the printer you're dealing with. Here's some. So these silver looking ones, they're not silver, they're brass, but they've been coated with nickel, and so they're trying to do somewhere in between. Maybe you occasionally print abrasive materials, but you really mostly print the regular stuff. These nozzles are good in that case. So what they do is they maintain the heat conduction properties of brass, but they have nickel coating on them, which will help a little bit with the hardened. Now this one says hardened steel, but it doesn't look hardened steel to me. It looks like the ones that are nickel plated. I don't see any. I didn't look for nickel plated, but usually the shiny silver ones are just a coating on the outside. So that coating is a little bit abrasive resistance, but most of the nozzle itself is brass on the inside. So those are the four big categories, and then one category being just the oddball stuff. Here's one of the ruby ones. So not quite of it as expensive as of the diamond. Here's a competitor to the diamondback. If I were going to get one of the diamond nozzles, I would get the diamondback version. Their process is they're sort of the originators, and they are, yes, it costs nearly twice as much, but it's probably going to be a better nozzle. And then there are some that have a ruby tip in there that are trying to do the same thing, just slightly less expensive than diamond. So it's an actual ruby jewel in there. And it's been machined to have the nozzle diameter you want. The other reason you might change your nozzle is because you want a different nozzle diameter. You want to go up to a larger size, so maybe a 0.8 or a 1 or even a 0.6. I normally have a 0.6, as is our problem right now, because this printer has a 0.6 in it. Or maybe you want to drop down to a 0.2 or a 0.3, or they make smaller ones, but they get harder and they get very finicky if you get really tiny. You would only going to want to go down to a smaller nozzle if you were really trying to print very fine details. You can get some very fine details that out of a FDM printer with a smaller nozzle. The problem is that those prints start taking really long amounts of time, unless they're tiny prints. So those are the reasons you might change wear. You want to prevent wear, or you want a different size diameter nozzle because of the application you're going to do. So in our case, it's mostly application. We want to get a little bit finer detail, and we want to go back down to a smaller nozzle. Here are a couple of notes on, we do want to print PETG. Now, yes, the G is a modifier, but it's not like an abrasive modifier. It's glycol. So PETG or PET or PET is like milk jugs and stuff like that. So it's a normal plastic that you use in a lot of applications. Actually, maybe not milk jugs. I think they're polypropylene. Just a vending machine bottle of water or something like that. That's usually PET. So the G, when they put the G in there, you could print pure PET. In fact, if I can dig it out somewhere later on in the quarter, we'll recycle some soda bottles, and they're just more or less plain PET, and we can recycle them, strip them up, and reform them into filament, and then print with them. But it's not quite as easy of a material to print with straight PET, so the manufacturers of filament modified PET to add this glycol group into it, and that makes it flow a lot better. So it makes the PET filament flow much easier, and you can print with it a lot better. I've got a little tiny bit. I went looking, and at least here at the house, I don't have a lot of PET sitting around for whatever. Actually, there's some, but it's in the printer. So let's see. It doesn't necessarily look any different. So this is a very minor bit left. So this is a Overture, and this is a PETG. No additives or anything. It's just regular PET, but it doesn't look any different. A lot of times PETG or PETG, whichever you want to use, will be translucent, and that'll be a kind of a giveaway that it is PETG versus PLA or ABS. I didn't have any of that handy. I do have some, Maybe I'll remember to bring it and show it in the future. Otherwise, it kind of looks like regular filament that you would use, but it does have some different properties. So it's got so PLA is stronger. Like if you put them in a testing machine, printed them all the same, it'd probably have stronger like tensile strength or some kind of mechanical properties. But overall, PETG is it's tougher, so it has some more give to it. It's got a little bit less rigid. It's not as brittle, and so a lot of times you'll switch to PETG. That's what we're doing with our airplane. These wings on the back would probably work better in PETG because it's got a little more flexibility to it than straight PLA does. So that's one reason we might switch to it. It's got good chemical resistance. Most of the plastics do, though. It's not like it's more resistant than other materials necessarily. It does have a little bit higher temperature resistance than PLA. So when you're printing something, obviously you print it at 200 or more degrees Celsius, but there's a point in the heating process called the glass transition temperature, and this is the point for thermoplastics where you get above that temperature and they begin to soften. And that point for PLA is somewhere in the 60 degrees Celsius range, maybe 65, it depends. But PETG is closer in the 80 Celsius range. So you've got, maybe a 20 degrees Celsius difference in when that PETG is going to start to soften versus when PLA is going to soften. And a lot of times that's the difference in this will work in this application versus this won't work in that application. And then there's materials with even higher glass transition temperatures. Like I said, it can be, not always, doesn't have to be, but it can be transparent. And so that gives it it's not clear, but it gives it a different optical property. So it just looks different. I was looking around to see if I have any. Sometimes I have I do. Here we go. Let me go get this. So here, this is PETG, and now it's pretty thick, so it's not like transparent, but it's translucent. And so you can kind of see, this is an ocarina, it's one of the ones from Thingiverse. This material is PETG, and you can polish it up pretty well. I think I did on this side at least spray some clear coat just to make it even more shiny. But this side is just the PETG polished. So just sanded, and I think I have some plastic polish and I polished it. So you can kind of get an idea of the translucency because that's some of the more translucent stuff. You're not going to get like a optically clear piece out of any of the material. There are some tricks you can do to make it better, but in general, they're not going to be clear like glass. But you can get stuff that light will go through. It doesn't shrink too bad, so you don't have to worry too much about warping when it's printing. It's pretty good about not wanting to do that. It does print hotter though. So if you have a printer like this one over here, actually I've modified this one a little bit, so maybe not quite like this one, but a kind of out of the box printer, and you have to be careful with some of them because they can't print hotter than around 240 degrees Celsius. We haven't really gotten into the all metal hot end versus not all metal hot end. We'll talk about that sometime in the future, but there are parts in the hot end part of some printers that can't go above 240 degrees Celsius without degrading. So most PETGs can print below that. There are some materials, not PETG, that they have to be 300 degrees Celsius or more. So you do have to know that if you're looking at a PETG, you want one that's going to print at least somewhere below 240. This one that I have, you can kind of see over here, 230 to 250. So that would work. you know, assuming that I could get away with the 230 to 240-ish range for the printing. And it does. It prints fine at 230-ish. You usually run a little bit hotter bed. So with PLA, the bed temperature 50. You can actually have the bed off if you want to, but you know, 50 degrees Celsius or something. For the PETG to stick down well, you normally want to be closer to 90 degrees Celsius. So your printer should be able to get up to 80, maybe even 90 on the Celsius for the bed. Ender style printers typically go to 80-ish, the Ender 3s. Print speeds. Now, print speeds are changing, right? Because there are more and more printers now that are designed for higher speed printing. PETG is typically still a little bit slower material to print than PLA, but you'll start to see more and more materials that have high flow properties. So they've got additives in them that make them print or printable at higher speeds. But so this number might be a little bit old, out of date for your printer if you have one of the Core XY style printers or something like a Bamboo Lab printer, something that's designed for a little bit higher speed printing. You could probably print faster than this. If you're using Cura and you've got a Ender 3 with the bed slinger, so the bed moves back and forth, you will print a little bit slower. Maybe not this slow, but it'll be slower. Layer height ranges, or there's nothing particularly special about PETG that makes you have to use different layer heights. So your regular layer heights, depending on how much detail you want and what size nozzle you have. The cooling fan is a different thing. I mentioned this last time that we talked about PETG. You generally want your fan, so the layer cooling fan, let's go to the printer here. Layer cooling fan is this one on the side. So, well, for this printer, it's this one on the side. We'll get that out of the way. So this fan is blowing, it's actually blowing down, and there's a little duct here that's shooting the air across. So that fan is trying to cool the part that's being printed. There should be another fan somewhere. So on this printer, it's right here. This fan is always on, and it's cooling the heat sink so that the filament does not melt up in the heat sink. The filament needs to only melt in the heat block area. So this fan, the one that's doing the part cooling, that's the one I'm talking about. And you probably want that fan set to 50-ish%. You know, not totally off and certainly not totally on. And somewhere in the middle, 50%-ish, is going to give you your best results with PETG. So here's what I normally do. Well, I gotta see what that says. Oh, it just says hello. All right, hello. I usually, for the first layer, maybe first 2 layers, I don't have the fan on at all. Usually, most slicers have a first layer fan setting that's separate from all the other layers. And so I don't have that cooling fan on at all for the first layer, trying to get it to stick down to the bed well, right? And then after the first layer is stuck down, I usually have it at 50%. So you can turn the fan completely off all the time for PETG. And if you do that, then it will be a much stronger part. Like the layers will be bonded together more strongly than if you have the fan going. But it's probably going to not look as nice. It's going to be a little stringy, might be a little lumpy, because you're not cooling the PETG at all, and it will probably be a little bit misshapen part. I'll answer the question in a second here. If you turn the fan all the way on, so 100% like you would print PLA, the part probably will print, but it's going to be very fragile. Like the layers between PETG layers would not be held together very well. It'll look okay, but it's going to have a poor interlayer adhesion, and the layers will come apart. The question was, if you wanted to build a custom printer, basing it off of an Ender 3, I probably would actually, because the Ender 3 is cheap, So this one started out as a Black Friday sale last Thanksgiving, and it was $99. So they're pretty cheap. And every part you can easily take apart. You've got all your necessary stuff. So you've got a screen, you've got a printer board, you've got a power supply, you've got lead screws and all that. There are several do-it-yourself kits out there that are based on taking a Ender 3 and maybe adding stuff to it or reconfiguring it. That's the cheapest route to go. Now, if you want high-end custom printer type stuff, then there's a different category. It's going to cost way more, but it is a fun build, and those are the Vorons and the rat rigs. They are fully custom. Like you can get kits that have all the pieces, but nothing is assembled. So you get boxes of extruded aluminum. You get a hot end that's just by itself. You get usually a Raspberry Pi for the clipper. You're going to run clipper on them. So, but those kits are typically in the, I think the cheap ones are in the $600 range to get all the pieces in. You can try sourcing all your pieces yourself. There is another one that if you have the skill to do it and a printer to print some of the parts, then there's the Rook. Wonder if I can find it real quick. Yeah, this guy right here. So this we don't need cookies. This printer, I just searched for the Rook 3D printer, and it came up on printables. It's an easier one to source, but it does have a lot of 3D printed parts. So you have to have an existing printer to print those parts or get them printed somehow. This is another good option as far as if you want to build, like if you just want the experience of building a printer, then the Rook is another somewhere in between. It's not as cheap as the Ender 3, and it's not as expensive as the Vorons and the rat rigs and stuff like that, and because you print a lot of the stuff yourself. You still have to go source a lot of pieces, linear rails and guide rods and a bed and all that kind of stuff. But so if those are the three broad categories. You take something like an Ender 3, you get a cheap one or a used one even. Cromwell, let's see if I can find them. Cromwell Tools, maybe? I'm not sure their website. Yeah, I think this is it. Now, I wouldn't get a Dremel printer, but I don't need these. Sometimes they'll have deals on refurbished printers that are cheaper. But so you can get a cheaper Ender 3, one of the old ones, and base your build off of that. You can get one of these, kind of print a lot of the parts yourself, but you still have to source some stuff, Rook style printers, or you can get a kit for a Voron or a rat rig or something like that. Or you can try to source those yourself. Normally, if you're sourcing yourself, unless you have a bunch of printer parts laying around, it's going to be more expensive to try and source yourself all the pieces versus just go and get one of the kits. Oh, you have so if you have an A1 Mini, it would print. I think the Rook is set up to where all the parts can be printed on something the size of an A1 Mini. It's a fun build. I have one, not here though, and you do have to go find your drivers and everything, your board and all of that. I think there is a company that makes a starter kit for the Rook, but it's a little bit easier to self-source all the pieces for. All right, so we need to change this nozzle. So let's go over here, and first of all, I'm going to remove this cover. Actually, let's see. Is our nozzle cam doing anything for us today? It kind of helps. All right, so let's get this cover off because you probably, let me see on this. I'm going to have to raise it up some. We could get the nozzle off. So there's usually a silicone sock covering it. So there's that. So there's the actual nozzle right there. We could get it off of there without removing the cover here, but I think it's going to be easier for you to see what's going on if I remove the cover. So this particular cover, there's 2 screws. Oh, I do have this CR Touch bed sensor on there, so it'll create a little bit of problem, but that's okay. So you may not have to do this step if you're changing the nozzle on your printer. You have to do this step. You got to take the silicone sock off. Yours will look a little bit different than that one, because if you have an Ender 3, because this is not a regular Ender 3 hot end that's on here. Okay, let's try not to lose any of our pieces. So we're changing the nozzle on this one because it has a 0.6 millimeter nozzle in it. I just looked at it, and it looks like it has one of the nickel plated nozzles, so it's somewhere between hardened steel and brass. So we'll move that over to the side. So a little bit different hot end, but they have all the same properties. You know, they've got a heat sink, a heat break that you can't even really see, a heat block, and a nozzle. So they all have that. We don't have to take any of this stuff off. We just need the nozzle. Now I'm going to get this thing out of the way somewhere. And let's make sure we're not melting this wire. Okay. So I'm going to turn the printer on. Oh, this printer is running Clipper. I forgot about that. So I've got to go. I don't think there's not much I can do on this panel. So I'm going to have to do some stuff over here. Let's see. The Clipper, we'll talk about Clipper later on in the quarter sometime, but this one is running Clipper, and so that runs on a Raspberry Pi, and so I've got to boot that up and get it connected. All right, I think we're connected now. See. All right, I have to do that so that I can get to this screen so I can turn the heater on. Oh, actually, I might have a little. I think I can actually do that on this one. Not all the time does this screen do anything when you're running Clipper, but in this one it does. It does. I do have a preheat PLA. So an issue here. Let's see if I can go back to the other one. An issue here is that I don't know if we can get it straight. That's straighter. That if you don't heat the nozzle, then there's a chance, decently good chance, that you will break something. So, oh, I see another question about the printer thing. Let me answer that really quick. Could an A1 Mini print PETG? Yes, almost any printer can print PETG. And that is a consideration when you're printing parts for a printer build. Most of the parts can be printed in PLA, PETG, but anything in the heat area, so if close to the heated bed or close to the nozzle, has to be one of the higher temperature materials, or they will form. Even PETG will deform. So you have to move up to ASA or ABS, which these printers can print. Those materials, we haven't talked about those yet. They need some ventilation or some sequestration or something, so that you're not breathing in the fumes of printing ABS and ASA. So, like I was saying, I need to heat this nozzle, so I'm just going to do preheat PLA. I don't need the bed, so I'm going to preheat the hot end. And it's going to heat up to 200. It just needs to be heated, because if you try unscrewing the nozzle without heating it, there's a really good chance that you're going to break either the nozzle itself. The threads are going to shear off, and you're going to have the threads left in the heat block. Now in this case, this one does This one has one of those dual type nozzles, so it is mostly brass on the inside, so that would probably shear. So you want to heat up the bed, or not the bed, the nozzle, and you want to hold the heat block. So I don't know if you have to be careful because it's going to be really hot. I'm going to hold the heat block with, I think I'm going to try holding it with an adjustable end wrench, crescent wrench. This one's not technically a crescent. This is a, this is just a generic one. So a lot of people call these crescent wrenches because that's the name brand of them. This is an adjustable end wrench is what the generic term is. So let's see if I can figure out how I'm going to hold that. I might have to get some pliers. I think I can hold it from this side. Yeah, I think it'll go just like that. So all you need to do is you need to find some way to hold that heat block from turning as you're trying to loosen the nozzle. So a couple of things you have to be careful of other than the heat is you've got you've got a wire, and you've got really tiny wires over here for your thermistor. So you don't want to break those wires. You're probably not going to break the heater wires, the bigger ones, but the thermistor wires are really tiny and they're pretty fragile. Also, you don't want to pull those wires out. Now, if you pull the heater wire out, then your heater, that's going to be obvious because the heater cartridge is just floating out there. It may not be so obvious if you pull out the thermistor wires because they're really small. And if you pull the thermistor wires out, remember the thermistor is measuring the temperature of the hot end. And if it is no longer measuring the temperature of the hot end, your printer's control system is going to get really confused because it's going to be dumping heat energy into a system and it doesn't look like the heat is going up because your thermistor's not, it's out in air somewhere. And it's going to have problems, and they could be really bad problems. Hopefully, your printer has a fail-safe in it called thermal runaway protection, which means that if the printer ever detects that it's trying to heat the hot end, but nothing's happening, so the thermistor is not reading an increase in temperature, it just shuts down. Because it could be that the heater's bad, right? But it could also be that the thermistor is broken, come out, quit functioning, and it really is heating up, and then it's not noticing it heating up, so it tries to heat up more, and it's still not heating up, so it tries to heat up more, and it can get so hot that you can actually melt stuff over here and cause fire. So be careful that your thermistor does not come out. Most printers these days have that protection built in, and they'll just shut down, and they'll give you an error on the screen or wherever your errors show up that a thermal runaway fault has been detected and it's shut down. If you ever see that fault, it's probably something to do with the thermistor. All right, we're heated up. Now I need a tool for the nozzle. So there's some specialty tools like this one. I've got some others over here. Like these little guys that have, socket type. And you can just use plain wrenches. So it is better if you have one of the tools that actually fits your printer. Your printer did come with, if you have nothing else, your printer came with a little flat wrench. I don't know if I have one. I don't see one of those. So I usually throw those away or don't do anything with them. But that little flat wrench, there is one that will fit there. That's the last resort, really. There's another tool. Oh, you're not looking at that. Let me show you that one. There's another tool type. Order of preference would be maybe one of these guys. This is a specialty one that I don't even know if it fits this nozzle. And I've got to raise it up higher to get on there. This one kind of fits, but it's a little bit loose. This one has a clutch in it that torques it to the right specifications. So that's kind of nice, but I don't think it really fits that nozzle. So then I would go to this kind. And then I would go to this kind. These are kind of equal. The main thing is you want one that's got a lot of mass because the nozzle is 200 degrees Celsius or more. I've got mine set at 200. And if you use that little thin wrench that comes with the kit, it will quickly, like 5 seconds or less, heat the entire wrench to 200 degrees Celsius, and you're holding it. So if you have one that's got a lot more mass, that heating process will take a lot longer. So this would be my next resort after these. And then if I had to, I really just wouldn't do the thin wrench. Maybe if you could hold it with some pliers or something, or do it really quickly. So I'm going to see if this, I don't remember which one fits. That one's too big. That one fits pretty well. All right, so I've got one that fits. I've got a decent amount of mass that's not heating up on me instantly. I do need to hold that heat block. So let's see if I can get this on there. It's being a pain all of a sudden. Did I close it up somehow? Also, this fan right here is running, so try not to get any kind of tools in there because that could give you problems too. Now this fit just a second ago. Oh, you know what? It did fit a second ago, but we've heated it up now and it's larger. So having trouble. Let me go get a larger wrench. All right, I'm going to go with the pliers. So got some Robo Grip pliers. All right, so you don't have to hold a lot here. You just need enough to where you're not twisting. Oh, that's the wrong one. Where'd it go? You're not twisting the heat block. Ooh, wow, that's tight in there. Oh, because I'm tightening it. Forgot I was going I'm upside down from, there we go. All right. So once you get it broken loose, if you want to, probably set that thing somewhere because it's going to be hot for a while. You could let it cool down if you were worried about you're going to get, oh, so let me show you this. I've got this warning. It is shut down because the heater is not heating as expected because it noticed something's weird. And you know, I've been messing with it. I've had those pliers on it, so they were wicking away heat. It's noticed already that, hey, something's different, so I'm going to shut down so I don't start a fire. So like I was saying, you could let it all cool down now if you want to. One thing I didn't say that I probably should have done is now this one doesn't have filament in it, but there could be filament down in there somewhere, and that'll be an annoyance if it is. But you would normally unload the filament. So I'm gonna see if I can get this nozzle out of here. And it probably does have filament in it, which is a little bit of a pain. No, it looks like I had emptied it already. So you do want to remove the filament if you can. So I'm going to shut it down now so that it will cool off a little bit, because the next step is I have to choose my nozzle to go back in there. Now I have a whole set here of those nozzles, and I'm just going to find the 0.4. Most of the time it's written on the nozzle, so I don't know if you'll be able to see it. Actually, that's a tiny one. I think that's 0.25. Let's see. All right, so here we go. And it actually, I might have had a 0.4 in there already. I thought I had a 0.6, but well, we were going to do a nozzle change anyway. So let's zoom in. There's the Raspberry Pi that's running this one. I don't know that you'll be able to see it. You can see it on this one. This one's kind of mangled up a little bit. That's the new one, and it says 0.4 like it's engraved on it. Sometimes it'll be engraved in there like laser etched. Sometimes it will be a series of dots of some sort, and sometimes it won't have anything. The really cheap nozzles don't say anything, and you just have to assume. One thing you can do is most of the time the nozzles come with those little acupuncture needles, and you can kind of gauge the size, assuming you don't have like diameter gauges, which you probably don't. But you can gauge the size of the nozzle based on the acupuncture. The acupuncture needles usually are 0.4. Yes, yes, some kind of the Knipex pliers or whatever. You just got to grab that thing with something. I ended up with the Robo Grip because my smaller adjustable end wrench ended up not working. The next step, which I'll go ahead and do probably, but you may want to wait a while because you've got to get something. You've got to get your hand in there to, oh wait, we were on the other camera, weren't we? I moved it around. You've got to get your hand in there to actually screw the nozzle into the heat block. But this part can be done cool. So it is not cooled down. I'll just try and not burn myself. Having some difficulties. There we go. All right, so you just have to get it started. And let's see, where's our tool at? I think it's this one. Our tool is actually still kind of warm. So you tighten it up to where it, all right, it just got snug. Okay, so by snug, I mean that I can tell that it's starting to tighten up. Before that, it was just almost no effort to turn it in, to screw it in. But now there's a little bit of effort there. So now I need to heat it back up. So I'm going to turn it back on. Hopefully it'll let me heat it up. We'll see. I'm going to restart the clipper firmware over here to see if it'll let me heat it up. Alright, it let me come back to it. It says it's 93 degrees. But I want to heat it up 200, even up to 240, 50. So similar to when I loosened it, except that now the point is I want it to be at printing temperatures and I want everything tight. So I snugged it up with the tool, just regular temperature. It was 100 degrees Celsius, but it could have been room temperature and it'd been fine. I have to grab this guy again, and I need to do about a half turn, maybe only a quarter turn, depends. Oh yeah, it's not gonna be it's gonna be like a quarter turn past snug. So a quarter turn past snug will heat tighten the nozzle. If I don't do that part, I run a chance of I tighten it down with room temperatures, and I go to print, and I didn't get the nozzle seated against the heat break, and there's going to be a super tiny, but it does exist, gap between the heat break and the end of the nozzle inside the heat block, and filament will come out of there. So if you've changed your nozzle and you start printing and filament is oozing out here or even down here, then you need to stop printing. You probably actually need to unscrew the nozzle, clean it all off. You might get away with doing this part now. Heating it up, holding the heat block, and then tightening the nozzle. I'm going to go ahead and turn it off. I just did the heat tightening. If you don't do that part, you probably will get some leaks. Now it'll print, but depending on the severity of the leak, you might have filament everywhere, which you probably don't want. So That would do the nozzle swap. So I'm pretty sure the one that was in there was a 0.4 already. I thought it was a 0.6, and so I had sliced everything as if it was a 0.6, but I think it says 0.4 on there. So, oh well. We didn't actually change anything, but we did change the nozzle. The nozzle size, nozzle type, material, none of that has an impact on how you're going to do this part of it. So then you would put the little silicone. Well, you'd make sure that your thermistor is still intact, looking right. Your heater looks right. Then you put whatever kind of heat sock on there. So this it helps trap the heat, so it's an insulator. Plus, it kind of protects against anything this might touch if it were not coated with the silicone. Then you put any kind of covering back on. I'll do that off stream. That's nothing. It's just the 2 screws. I do have to get this guy back on there. Then there is one other thing you need to at least be aware of. It could be that the nozzle you took out of there and the nozzle you put in are slightly different lengths. Well, I can't. Slightly different. My hand's in the way. Oh, let's look at the other one. That one. Like they're slightly different lengths here, and your Z distance is no longer accurate. So you may have to do a Z offset again, or just do home all, and then drive your machine to a known Z height. So Z equals 0, or if you've got some kind of particular tool that measures a certain height. Remember, I use the 16 millimeter metal die, so that's kind of like, I know that's 16 millimeters. So I would go to Z equals 16 millimeters and then see, is the nozzle actually 16 millimeters above the bed. You do need to at least check that to make sure that you haven't changed the Z offset in any way, because it is possible that the nozzle you took out and the nozzle you put in are not quite the same. There are definitely some where that's true. In this case, these are the exact same, they came out of the same box, so they should be the same height. And I am using, although this probe isn't measuring the nozzle, so even the probe could tell me the wrong height because it's not the nozzle that it's measuring. All right, so that's a couple more things. Probably on Monday, hopefully on Monday, we will have these printed that we can test out. I've printed this one partially, but then I thought I had, I did mess up. So I sliced for 0.6 millimeters, but thinking that the nozzle in there was 0.6, but it was only 0.4. That was my actual problem. I thought it was the other way around, but that was my problem. All right. We will be back Monday. Probably on Monday we'll do some more modeling on our jet. So he's still around here somewhere. It's over there. And should have these printed in a PETG. I don't know if I have a black PETG though, so we'll have to see about that. Maybe we can get one. And we'll do a different, we've been doing the take a picture and model in Fusion. I think we'll try to do some of the scanning type of modeling and see if we can get that to work for our next piece that we're going to work on. All right, I'll be back on Monday at the regular time. We're just now at our regular time, but I've got to get to this other thing that we're doing this week. So Monday should be back at 8 o'clock. Again, the videos stay up indefinitely, so you can watch them whenever you want to. All right.